Good morning to all of you, all of you, all of you.
Good morning. Nice to see you after a long time.
It's a pleasure. It's a pleasure.
It's a pleasure.
That
Professor Deka,
from all of you.
yes. হেৰি জইন প্ৰশান্ত জইন কৰা নাই নেকি?
স্যাৰ এতিয়ালৈকে কৰা নাই, কৰিব চাগে, কৰিব তেওঁ প্ৰশান্ত কৰিব আৰু আমাৰ অনুপম শইকীয়া জইন কৰা নাই নেকি?
আমাৰ হেৰি মানে শুভংকৰ মানে ঠিকে ঠাকে আছে নে?
শুভংকৰ ঠিকে আছে স্যাৰ।
Okay, okay.
Yes, sir. Yes, sir.
He is my important man. Shubhankar.
Yes,
Good
sir.
morning.
Good morning, sir.
Shubhankar has the key for you.
Oh, it's a pleasure. It's a pleasure.
Who will be in the audience in this meeting?
Sir, our meeting of the audience will be our Aryabhatta Science Center people, then our college environment sales, our Assam Science Society people are there.
Okay.
Then from outside also different state assembly council people. আৰু গভট অফ ইণ্ডিয়াৰো থাকে দুইজন।
Students থাকবো নে?
Students খুব কম।
Students ইনভলভ কৰিব পাৰিলে অলপ ভালে আছিল নেকি?
হয়, কিন্তু এতিয়াতো নহ'ব আৰু আমি এইটো তেনেকৈ কৰাও নাই বস্তুটো।
ঠিক আছে।
আৰু গতিকে ইউটিউবতো বহুতখিনি অডিয়েঞ্চ থাকে।
But basically largely academics or academic governance.
হয়, academic governance, mainly academic governance.
Right.
Yeah. Can we wait for 5 minutes?
Yes, yes.
Yeah.
And we are waiting for the director, isn't it?
Yeah. She is not keeping well actually. Still, she will join.
Mr. Abdul Kader, can you please stop the presentation?
I think our director will join.
Hello, good afternoon. Hello.
Yes.
Bhojan Deka, আপোনাৰ mute কৰি ৰাখিবচোন আপোনাৰ।
লেকচাৰখিনি আছামিছত ক'লে আমাৰ সুবিধা।
Good morning, Joydeep.
Yes, welcome. Good morning, ma'am. So, shall we start? Can we start, ma'am?
Yeah, we can start. Can you hear me? I can't speak louder than this.
Yes. We can hear you.
Okay.
So, good morning, everybody, and welcome to this edition of Vigyan Utsav, Azadi Ka Amrit Mahotsav. I think it is the 10th edition. For last about 10 months, we are organizing this event in a virtual mode to celebrate 75 years of India's independence in the form of Azadi Ka Amrit Mahotsav. So today, the main theme is, every month we are having a theme. Today, the main theme is basic science for Atmanirbhartha. Very important topic. So I don't want to delay. We have with us eminent speakers of this deliberation. Before that, I welcome Director Estate, Madam Kimni Changshan. I request Madam to welcome all the esteemed speakers, delegates, with her views and kind words on the theme of this month. Eminent speakers, this is over to this deliberation. Director Estate. For that, I welcome Director Estate, Madam Kimni Changshan.
Thank you so much, Dr.
I
Jaideep.
request Madam to welcome
A
all
very
the
good morning,
esteemed speakers,
each and every one
delegates.
of you. I'm really happy that I could get this opportunity to be able to address Utsav today again. I hope you can hear me because just I'm still feeling very weak due to COVID. I cannot use my usual tone. So I hope I'm audible to I thank every one of you today, and I would like to extend special welcome, especially to the esteemed speakers, Professor Alakumar Buragopa, former Vice Chancellor, Dibrugarh University, Professor Pannalal Swami, retired Professor of Law College. Something is making very noise. I don't understand.
I request all others to kindly mute their microphones.
Dr. Prasanta Satya, Department of Physics, Dibrugarh University, Professor Anupam Saikia, IIT Guwahati. I also extend my heartiest welcome to all the participants who have taken out their valuable time in joining us today to be a part of this program. We are celebrating Vigyan Utsav, Festival of Science, which is being planned under State Science and Technology Program of the Ministry of Science and Technology, Government of India, and with month-wise themes. The theme of this month, as you all know, for this youth is Basic Science for Atmanirbhartha. So, the word basic science usually refers to pure science studies and research that aims to expand our scientific knowledge base. Basic science is aimed at gaining a better understanding of a subject, phenomenon, or basic law of nature. The majority of scientists believe that advancement requires a basic foundational understanding before research. In other words, basic science builds the groundwork for subsequent application. The goal of basic science is to understand how things work, whether it is a single cell, an organism made of billions of cells, or a whole ecosystem. Scientists working on basic science questions are simply looking to increase human knowledge of nature and the world around us. For example, botany teaches us how plants grow, how plants synthesize food, why their leaves are green. Physics teaches us why things fall, what produces light, etc. Mathematics teaches us what numbers are and how they are evaluated, what equations are there. The culture of basic science is built for knowledge. Understanding the basic sciences establishes a core from which to build upon for greater understanding and understanding of basic science. Basic sciences are vital to gain sustainable development and to improve the quality of life for people all over the world. The challenge is to tailor our needs so that a vertical integration of science is maintained, that the bank of knowledge that we have in basic sciences is not lost and can be transferred from one generation to the next, resulting in transforming discoveries and their application. Our scientific policy resolution says the key to national prosperity, apart from the spirit of the people, lies in the modern age, in the effective combination of three factors: technology, raw materials, and capital, of which the first is the most important. But technology can only grow out of the study of science and its applications. That is why promotion and culture of basic science for technology development and application is very important for achieving an Atmanirbhartha Bharat. I am confident that today's deliberations will highlight these issues, which will be a big benefit to all of us. With these words, I would like to end my inaugural speech and thanking everyone, wishing you all a wonderful day. Thank you so much.
Thank you, madam, for your kind words and setting the tone for today's deliberation. Now we are going to our main technical presentations. Today we are very happy to have with us former Vice Chancellor of Dibrugarh University, Professor Alok Kumar Buragohain. And he is also now closely associated with the academic affairs of Royal Global University. Professor Buragohain is a very well-known biotechnologist of this region. He has a significant contribution in the field of like drug discovery from medicinal plants and other natural products, drug discovery from medicinal plants against Mycobacterium tuberculosis, diatom nanotechnology, evolutionary genomics, petroleum biotechnology, and different other things. And also, he has immense contribution for science communication in the state. He is associated with Assam Science Society. I think today this deliberation will highlight how I request all others kindly to mute their microphone, otherwise some noise is coming up. I think today his deliberations will be able to highlight the significance of this theme, basic science for Atmanirbhartha, because now our country is having that slogan, the Atmanirbhar Bharat, how this basic science can help us to building an Atmanirbhar Bharat. Before inviting Professor Buragohain sir, I also welcome our friends from the Department of Science and Technology, Government of India, Mr. Vigyan Prajapati and others, and also from the other state assembly councils. So I now invite Professor Alok Kumar Buragohain sir to kindly deliver his keynote address. Sir.
Thank you. Esteemed Director of ESTEC, other distinguished panelists this morning, named as Vigyan Utsav, under the aegis of the Azadi Ka Amrit Mahotsav, 5 years of our independence. So, Pannalal Goswami, my old colleague in Dibrugarh University, then Anupam Saikia from IIT Guwahati and others, and also other participants, organizations, and also others. Gratitude to the with all of you. Have come to know and understand in the meeting in this their academic IT teachers, college teachers, then also people who are involved with academic governance, either as officials in the Science and Technology Department, ESTEC, and other state science and technology environment councils of the country. So therefore, I have, I have sort of a speech in the sense that I was initially thinking that a large number in the audience will be
Abdul Kader,
Please keep microphones muted. I am just rescheduling my my speech, brief speech. It's about 20 minutes. But then initially, as I said, I prepared mentally. I prepared something for the youngsters as we are celebrating 5 years, and what a hard-earned independence that was. I think young people have to know, not only in terms of our struggle to win independence, the political independence from the British, but also to establish ourselves in the world. Our might, involving our knowledge system, science and technology, and whatever. So therefore, Azadi Ka Amrut Mahotsav is not a celebration simply of our political independence. We have a very solid, profound science and technological and knowledge on which we can really be globally competitive and from all over the world. So that is one very important point that the young generations have to understand and appreciate, that this is what they inherit and this is their responsibility. Very briefly, I will highlight on three very important aspects with regard to independence, as we call it, Atmanirbhartha, with respect to technology. Now, we have to look back, and in the history, you see, we have one knowledge system of the world. When there were no civilization elsewhere, we were at the pinnacle of civilization, and we had the universe, of the cosmos, of life, its meaning, its biology, not only biology, the deeper meaning of life, beyond life, as you understand the philosophical aspects of it. We had a thorough understanding and concept about the whole universe, cosmos, and the people and everything. Now we are talking about sustainable development, but these concepts of sustainability, writings of the ancient scholars, these are all there. The fundamental of mathematical science, I will have to repeat it because all of us know. The fundamentals of today's science and technology, computer science, mathematics, was not invented zero. I think the rest of the system that we have cannot imagine. So similarly, we had many contributions in the field of medicinal science, medical sciences, Ayurveda, yoga, whatever. It is coming up now. But then it was done, it was established thousands ago in India. We were really Atmanirbhar from day one. And now we have to realize that what kind of potential we have at present. And coming I think we can see n number of I will what kind of science, what kind of geometry, what kind of architecture, what kind of design had gone into the construction, designing and construction of the can you imagine construction of Kamakya temple up there in the hill with that kind of stone, rocks, apart from the artistry, the science, look at the geometry, if that had gone into the design page, 700 years buildings, what kind of materials did they use? Steel and rocks and timbers that we use in our today's construction. They use a totally different kind of constructions which can withstand and which have been found to be withstanding very high seismic forces. Do any damage to these structures, Ronghar, Taratal Ghar, whatever you see. Look at the knowledge of hydrology of those the homes. You just have to see the Joykhagar, Gorikhagar tanks. The water levels are above the ground level. They knew, they perfected, they not only knew, they perfect the art of water purification by using mercury treatment. So I think we had to, they had tremendous knowledge of metallurgy. They had tremendous knowledge about. So these are all there as a historical baggage that we have with us. But the only thing is that these are done by anonymous scientists. We cannot pinpoint these were done by some, anonymous, numerous and anonymous. Very close at the national level, at the regional state level. I just indicated a few that have come to my mind immediately. But then even in the recent time, you just notice what our Indian scientists have done and changed the entire scenario of industry. Silicon Valley, it started with fiber optics, it started with Hotmail, it started with USB. And all these were done by Indians. And they were not trained in Europe or America or any other place. They were trained in, and not in the IITs. Many of them were not trained in IITs. Sabir Bhatia, then Dham, then Ajay Bhatt. These are the people who were responsible for laying the foundation of modern, IT revolution. So these are all, role models can be our own prowess of science and technology. So we have to really look into it. But the question is now that brings another example. I cannot help by coming up with the vaccine, and for the first time we have seen that our industrial scientists are and others, they have come up with these novel vaccines. We were the world leader with respect to vaccine production, to only the technology part, but the underlying of it. A strong foundation, biology, human biology, and that really propelled us to this status of being the world leader in the health. We are truly not only independent with respect to healthcare system, so who are being held by our vaccines and our medical supports. So this is the present. Mention about the past. Now, how to take it forward? Now to the academics, because we are all fellow teachers. We spent a lifetime. Now, we teach a lot of science subjects, basic science subjects, physics, chemistry, mathematics, geology, all these things we have been teaching to our students. But what is not being able to what they call as valorize in the commerce and business. It's technology, everything we teach. And I think this amendment of which would understand and appreciate that what they have been taught in physics and chemistry and biology can be developed into some kind of production service for the really make us independent in This valorization has to happen. Valorization means, putting value to the knowledge that we give them. Embedding the entrepreneurship science education is very important. European universities, they have already started the, what they call it, entrepreneur science embed some program they have developed, and in which they're embedding the element of entrepreneurship in their science subjects in the curriculum, so that students not only gain the knowledge, but they also have an understanding of the value of the science that with which they can take that knowledge, developing products and services, and which will take them as an enterprise, as an entrepreneur, to the market. And it is this which is very important to my mind, because it is this between what we impart them as knowledge in pure science, is also enabled to be appreciated in terms of its application in business. Many IITs, many universities in the country and abroad, I know of at least several ones. What their doctoral research, in mathematics, computer science has given rise to formation of companies. At least one student from Assam, I know, he was basically an engineer turned mathematician, and he did Bangalore, and now he has developed a cybersecurity company which has got global presence. Many companies, many drug discovery companies have in university biology departments, biochemistry departments. So I think this transition from knowledge is very important to make a country Atmanirbhartha or independent. This is very important to my mind, and I think there are 2-3 elements, because professionally we have to know as teachers how to embed particular component on the curriculum of physics, science, physics, chemistry, mathematics, and other basic sciences. How to embed it, how to relate it. It requires a lot of research. Secondly, also how to give the students the basic ideas of entrepreneurship. What is the science and commerce of entrepreneurship? How can development? So that attitudinal development has to be developed. And then transfer, the industry, academia interfacing, and all those things will come. Please remember, I have been examining the syllabi and the students' outcome. And even in our country, the students who take up entrepreneurship with their subject is already there. Or business management, they somehow develop an attitude so that with their knowledge they can straight head for the market. This embedment has taken place in commerce and management syllabi, even in our country. So this has not happened to my mind, so far as we have to think about it, and if we can embed entrepreneurial science, entrepreneurial concepts as a curricular component in the curriculum of the basic sciences, I think that would be a way forward to make even had a lot of examples for the young people from the past and the present on science and technology, how Indians are doing. But then I think there is no point telling, because we all know about it. The audience is very learned. But then the last point to my mind, we have to redesign our curriculum. The knowledge in terms of business. So I think these are my humble observations. I wish all of you grand success and congratulate Dr. Joydeep Bora, Srimati. Hello.
Thank you, sir. Thank you for your very important deliberation. In your deliberation, you have covered many areas like appreciation of basic science and its application. Because if we always need appreciation of the people and political wisdom for spread of this basic science and basic science research, then how to embed the basic science in our curriculum. These are very important issues to attract the new generation, young generation for the culture of the basic science. I think your keynote address will certainly help us in understanding the importance of this theme. Now we are moving on to our next presentation by Dr. Pannalal Goswami sir. I think all in this virtual meet today, particularly from our state, need no introduction about Professor Pannalal Goswami. Professor Goswami was a professor of Cotton College, now it is Cotton University, our teacher. And our generation in Cotton College always was immensely benefited by teaching chemistry by Professor Pannalal Goswami. He is a very very good motivator for the student, and his lifelong effort for popularizing chemistry through hands-on experiments and science behind miracles and all these things has attracted large number of students for taking chemistry, and getting interest in chemistry. So when this topic was announced by Minister of Science and Technology, sir, the Professor Goswami sir's name immediately came to our mind, and he should be there. He will have some different. He is coming out of this traditional presentation. You will see how he's going to present. I think it will benefit mainly whoever the teachers present here. They will be greatly benefited. I welcome Professor Pannalal Goswami sir for this presentation, sir.
Hello, good morning to all my viewers. Thanks to Jolly. Today, I'm going to tell you one very interesting story which I have faced during my professional career. One day I was telling my students regarding the combustion. I think you know what is combustion. Combustion is simply firing something and something is getting burned, is not it? So in this way I was telling them, oh, you see, actually when our forefathers first learned about the fire, the invention of fire was there, and they were using this fire for combustion purpose. How they were using this fire for combustion? They were just roasting their food, that is the raw meat at the beginning, and they were just using it. They were using the heat of this combustion. Say what material they were just say making to burn. They were at the time they were getting only the dry wood, dry leaves, etc., and they were burning it, and they were getting the heat. And so by that heat they were just protecting themselves from the very severe cold in winter season. And also they used to just scare the wild beasts from their lethal attack by this fire. Now, whatever it is, the fire Actually, they are using it for combustion purpose. At that time also they were using, and after that we have crossed such a vast time. And now here we are in, say, 21st century. Remember, in this 21st century also, we are very much dependent on this combustion process. How come? The overall mobility of us is dependent on this combustion. How? You see, actually, the cars, the vehicles, these are running on road, then your train, your ship, your aeroplanes, all these are running and all these are making us to move. And we have achieved this particular state of civilization. Now everything is depending on this combustion. Combustion of what? Combustion of your petrol, diesel, then your aviation fuel, even coal, your natural gas, all these things are subjected to combustion, and the energy generated out of this combustion that is being utilized for our. Is it only the use of combustion? No. The major quantity, the vast quantity of your electricity, this one is also being produced by the combustion of coal, and your thermoelectricity you are availing. Forget about all these things. We are cooking our food, and for cooking our food, they also we are using this combustion process. Now, what actually this combustion means? Combustion is nothing but you are burning something by the help of your oxygen from air. Oxygen from air you are using, and you are burning all the things, and you are generating the heat and all these things. So this is the oxygen of air which is being utilized. How this is? What is the role of the oxygen? Yes, oxygen is doing the so-called fuel. Oxygen is burning your coal, which is carbon dioxide, and the coal or this but so whenever such a fuel is subjected to liquid oxygen, the reaction is very much exothermic. It is involving a tremendous amount of heat. And that heat is utilized, that heat energy is subjected to your, say, just transformation from one energy, say, to your mechanical energy and other energy, electrical energy, this, that, vagara, vagara, all these things. Okay? When I was telling in this way, suddenly one of my students, he stood up and said, "Sir, I've got a question. You are again and again telling that it is the oxygen of air which is being used for your combustion purpose. Now, the question is, in our air, we are having only 20% of oxygen and 80% of nitrogen. And some other, say, quantity of your inert gases and your, say, greenhouse gases, this are there. Now, the question is, how you are so much sure that it is this lower percentage of oxygen is only reacting and this larger percentage of nitrogen is not reacting during combustion? What is the proof with you? If I say it is the nitrogen reacting, how can you tell that I am telling wrong things? Oh, at once the whole class started laughing at him. Then I had to intervene. I told them, oh, don't laugh at him. He has asked a very beautiful question, very much pertinent. Then I said to him, okay, gentlemen, I am taking it that yes, as per you, during combustion, it is the nitrogen is reacting. Now, if nitrogen is reacting, then it must combine with your fuel. Now, let us take something to burn. So, say we are taking a metal. If that metal is burning, then according to you, metal should combine with nitrogen. So metal should give you the corresponding nitride. And if this nitride is found as product, now if this nitride is treated with water, this nitride will undergo hydrolysis. And on hydrolysis, this nitride should give us the corresponding oxide of this metal and ammonia gas. So in that case, we will get the smell of ammonia. Is not it? If we get the smell of ammonia, we'll accept your hypothesis or whatever you have said. But if it's not there, then you should be convinced that what we are telling you that is correct. That during your combustion or during your burning, it is the oxygen of air is reacting. Okay, for this one, let us see one video. So, video number 1, please. Yes, Shivankar, video number 1, please. Okay, gentlemen, here you see what this is what your electronic weighing chemical balance. Your electronic chemical balance. Oh, he has inserted one beaker inside it. Okay, here he has taken magnesium ribbon. It's a metal, and he is weighing that magnesium along with the beaker. You just observe what is the weight. Oh, yes. It is how much? It is 196.937. Okay, you keep it in mind. You keep it in mind the weight. Now, as soon as this magnesium will be burnt, then what it will happen? It will be combining with something from air, is not it? And then we will collect that ash inside that beaker. Okay, he is burning it in the flame. All right, you see, oh, such a brilliant flame is coming out. Okay, he is taking it inside the beaker. He has covered it with the lid. Yes, it is cooled down. And now he is taking the weight. He is taking the weight. Okay, pause, please. Okay. Now, here the ashes are there. Is not it? So, what is your expectation? We have burned magnesium. Now, is it that the weight of these ashes will be more or less? What is your expectation? Okay, unpause please. Unpause please. Okay, you see the movement now. You see the weight now. How much? How much is the weight? How much is the weight? Let's see. Let's see. Oh, yes, it is now 197.055. Earlier it was 196 point how much? Oh, what a 937. Now the weight has increased. So what is happening? Something from air, it has reacted with the magnesium, and so the product, the ashes, it has just, okay, unpause please, unpause please, unpause. Okay, the weight has increased. But till now, we don't know what is the matter. So, okay, he is now taking out the beaker. All right. So, you just observe what he's doing. So, here he will be, okay, here he is adding some water to it. Okay, on addition of water, okay, he's just swirling it, the ashes are reacting with water. And now you observe what he's doing. Oh, he's sniffing. Oh, he's nodding his head. Oh, he is not getting any smell. He is not getting any smell. Oh, what a beauty. He is not getting any smell. So it indicates what? No smell of ammonia is found. Oh, keep it in mind. No smell of ammonia is found. Okay, he is filtering it. And, all right. Okay. 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 Oh, he's taking it in the, say, test tube. And now what he is adding there? You see, he is adding there your phenolphthalein. Very good. What happens to this on addition of phenolphthalein? Oh, it has become pink. Ah, beautiful, beautiful, beautiful. It has become pink. So it shows that the material that the ashes on treatment with water, here you see the equation. So the nitrogen is discarded, and now it is the magnesium, which one is reacted with your oxygen during burning, and your magnesium oxide is produced. Magnesium oxide on treatment with your water has produced your magnesium hydroxide. Magnesium hydroxide is alkaline in nature, and on treatment with phenolphthalein, the phenolphthalein color has attained pink coloration. Now this is the equation. If your nitrogen would have been there, then with magnesium, nitrogen would have reacted to give you the magnesium nitride, and this magnesium nitride on treatment with water, it should have given us magnesium hydroxide and ammonia. Am I clear? Please. Pause please, pause please, pause please. Okay. Now you see, since the ammonia was not found during the reaction, so now we can conclude what? That yes, it is the oxygen from air, it is not the nitrogen from air where that it has reacted. Am I clear? Now another thing you remember, this nitrogen is not at all a very good reactive reactive element under ordinary condition. Okay, and that's why nitrogen is used as the inert gas. I think all of you have, enjoyed your potato chips, etc. So the packet, that inflated packet, only small number of chips are there inside. But the inflated packet you have observed. Now nitrogen gas is inserted during packing. What for? Because nitrogen is inert, it is not so much reactive, and so it preserves your these potato chips. And not only that, in your food industry, this inertness of nitrogen is utilized. So okay, again, now what happens? The student, he is telling, sir, I have seen your experiment, but the thing is this, yet I am having some doubt about this oxide of oxygen. Then I told him, okay. Now, if we show you the character of another element's oxide, another element of the same group of the periodic table, and if we show you that, yes, what we are telling, it is correct, then you will be convinced. So okay. So please unpause it. Okay. Let it go. Now you observe. Now actually we will start with calcium oxide. Now what is calcium oxide? Calcium oxide is called quicklime, which is obtained from your limestone. Limestone is what? Limestone is your calcium carbonate. He is introducing some solid calcium oxide. This calcium oxide is obtained by calcination of your limestone, the calcium carbonate. Calcium carbonate on strong heating, it decomposes and it liberates your carbon dioxide, and so the remaining one is calcium oxide. I think you are convinced that calcium oxide is there? Okay, he is adding some water to calcium oxide. What happens? This calcium oxide, initially it was not hot, but as soon as water is added, a tremendous amount of heat will be evolved, because hydration of calcium oxide is highly exothermic. And here you see the bubbling is there, and also a good amount of steam is also raised. अरे भाई ये अभी on hydration वो चूना बन गया है. चूना, अरे वो हम लोग पान में जो खाता है, अरे भाई वो खोइनी बनाने का लिए वो जो चूना यूज करता है, that one. Okay. This is your hydrated calcium oxide. This is calcium hydroxide. All right. Now mind it, this is called slacked lime. So he is adding some good amount of water to this slacked lime, and what is happening under the hot condition, some quantity of your calcium hydroxide, it will get dissolved in that water, and so he is doing that. Okay, he is putting some cotton to filter. Okay, he is collecting the filtrate. Now mind it, he is collecting the filtrate, and that filtrate is termed as what? A very colorless solution that is termed as our lime water. Very good. He is collecting in a filter. Okay. Very good. Oh, he's correcting another guy. I don't know what he'll do. Oh, he has added some water too. He is adding some water, just increase the volume, nothing else, nothing else. He is increasing the volume. And what he will do? He is adding the phenolphthalein solution. Oh, beauty, what it is? Oh, on addition, it is turned pink. Okay. Pause. Oh, no. Allow. Unpause again. Okay, he is doing what now? To another teacher, he is just blowing air by mouth. Oh, what is happening? That transparent, colorless lime water is turning milky. Oh, I am not going to tell what is happening. Here, you know it better, and you tell your students accordingly. You explain. It has nothing. It has got nothing to do with your this oxidation or your say combustion, etc. Okay. Now come to now come to it. So here you see, this is the calcium oxide and calcium oxide on hydration. So you pause please. No. Uh, so, so stop there. Okay. Pause. Now you see, this calcium oxide, calcium oxide we have taken knowingly. Calcium oxide on hydration, it is giving you calcium hydroxide, a tremendous amount of heat was involved, and this calcium hydroxide on addition of your phenolphthalein, it is turned pink. Okay, so now let us move in a retro fashion backward. So from pink color was because of the calcium hydroxide formation. Calcium hydroxide is basic in character. This calcium hydroxide was obtained via hydration of calcium oxide. If we go in a similar fashion in our previous case, which we have done with the magnesium ribbon, then also we can say the pink color was obtained from the ashes, burnt ashes hydration. So the burnt ashes must be the magnesium oxide, is not it? So I think now I am clear. And remember, this magnesium, calcium, strontium, barium, radium, all these are on the same group of the periodic table. So you know it very well that the elements present in the same group of the periodic table, they show similar chemical properties. So being based on that, the comparative study, so we have come to the conclusion that yes, during our combustion, it is the oxygen which has reacted with our metallic magnesium. Now the question, the metals, you have seen that metals on oxidation will always give you the basic oxide. As you have seen, the say corresponding hydroxide bases are obtained. Okay. Now, let us see another thing. Let us just say something more, that the metals on oxidation will give you the basic oxide, and the non-metals on oxidation will give you the acidic oxide. Let us consider that we are burning carbon, we are burning sulfur, we are burning phosphorus. In that case, carbon will give us carbon dioxide, and carbon dioxide will become what? On addition of water will give you carbonic acid. Let us consider phosphorus. Phosphorus will become phosphorus pentoxide on combustion. That is on reaction with oxygen. So on oxidation, it is giving you phosphorus pentoxide. Phosphorus pentoxide will, on hydration, it will give you phosphoric acid. So also you burn sulfur. Sulfur on oxidation will give you sulfur dioxide. Sulfur dioxide with water will give you sulfurous acid. Okay, in this way, the oxidation is giving you the different types of your oxides, other acidic oxide or basic oxides. Now, gentlemen, a question. Is it that for oxidation purpose, only the oxygen is responsible? No, there are lots of your what? Lots of your oxidizing agents present, which are being utilized by the different chemical industries and laboratories for oxidative purpose. Now, some of them, let me tell you that ozone, other than oxygen, ozone, then hydrogen peroxide, your chromium trioxide, acidic monochromium trioxide with acetic acid, monochromium trioxide with dilute sulfuric acid, then your chromate, dichromate, of course acidic, and then your say permanganate neutral, permanganate alkaline, permanganate acidic. So in this way, so these are there. Then your say pyridinium chromate, pyridinium chlorochromate, osmium tetroxide, selenium dioxide, even your halogens are also good oxidizing agent. And next your say your cupric ion, alkaline cupric ion, that's what you are getting in your saline solution. Then your alkaline silver ion, you are getting in your toluene. So in this way, so many oxidizing agents you will find which are being utilized for our oxidation purpose. All right. Now, let us now tell you that do you think that this oxidation is a discrete reaction? No. Whenever there is oxidation, mind you, side by side, some reduction is also taking place. Let me tell you here. Here, oxygen has oxidized your magnesium. That's what you have seen. Now, this magnesium has done the reduction. Magnesium has reduced your oxygen to oxide. So, similarly, whenever an oxidizing agent is oxidizing something, it itself is getting reduced. So your oxidation is always associated with your reduction. As a whole, we say that these are all redox reactions. Am I clear? Now, let's another video where we will enjoy this, how these redox reactions are taking place simultaneously, we will enjoy. Okay, the next video please. Next video please. Next video. All right. Here you see what he has taken. Oh yes, he has taken potassium chromate. Mind you, this potassium chromate is a good oxidizing agent. Okay, so this chromate is taken in a beaker. Very good. And so he is adding some water. Okay, the chromate solution is produced. Oh yes, this chromate solution, it is colored yellow. Okay, it is capped. Now he is taking, yes, this is your sulfuric acid, dilute sulfuric acid. Yes, he has taken in another beaker. So dilute sulfuric. Oh, what is this? This is your sodium sulfite. Okay, right. This sodium sulfite, well, say this will be subjected to your oxidation. So sodium sulfite on oxidation, it will produce sodium sulfate. Okay, he is adding some water and preparing the solution of sodium sulfite. Sodium sulfite Na2SO3. All right. Okay. Now he is taking the chromate and he is adding to sulfuric acid. Oh, you see, what's the color of the sulfuric acid? Sulfuric acid has attained your pink color, but it is because of the formation of dichromate. Now this is the acidic dichromate is colored orange, and so what happens now when this acidic dichromate solution will be added to your sodium sulfite? You observe. Okay. The sodium sulfite is colorless. Now as soon as this orange one is added, oh, it is becoming green. Oh, fantastic. It is becoming green. Beautiful. The green colored solution is produced. Okay, pause. All right, here you see. The yellow colored solution is our potassium chromate, and potassium your dilute sulfuric acid. It has become orange in color. Very good. When this orange colored material is added to your sodium sulfite solution, the solution is turned green. Now, in both of your potassium chromate and dichromate of your dichromate solution, the oxidation number of your chromium was 6. And as soon as it is added to your sodium sulfite, these higher oxidation states of chromium, it has oxidized your sodium sulfite to the corresponding sulfate. And itself is reduced to the chromium 3 ion. The chromic sulfate is produced. So from chromium 6, there is reduction to chromium 3. And here the reduction is taking place with respect to the chromium. And what has got oxidized? Your sulfide got oxidized to sulfate. Of course, the sulfate, you will not see any color because the sodium sulfate is colorless solution. So here you see such a beautiful reaction of your redox reaction, means the oxidation and reduction is taking place simultaneously. Okay, unpause please. You see another example. You see another, oh, here this is the equation. So potassium chromate on addition of sulfuric acid, though it is written K2Cr2O7, but mind it, it is H2Cr2O7 because here it is the dichromic acid is produced. Okay, no problem. Now this sodium sulfite is added, so your Cr2SO4 thrice. Here in the green state, the chromium's so valency is 3, means it is in chromium 3 oxidation state. And here you see, earlier we started with sodium sulfite, Na2SO3, but there in the product, you are getting only the sodium sulfate and potassium sulfate. No sulfite is there. Sulfite is converted to sulfate. Okay. Next, say unpause. You see another example. You see another example. Oh, what he is taking? Oh, yes, this is potassium permanganate is being taken. He is taking a pinch of potassium permanganate on this beaker. In the beaker, a pinch. Okay, very good. And now water is added. Oh, this neutral permanganate solution, it is colored purple. Very good, very good, very good. Okay, kept. And now what he is taking? He is taking dilute sulfuric acid. Very good, in another beaker. Okay, dilute sulfuric is taken in another beaker. It is kept side by side. And again, he is taking sodium sulfite in another beaker. Sodium sulfite solution is again made. Okay, all right, so it is kept. Okay, now you observe what happens to your neutral permanganate when it is added to your dilute sulfuric acid. You see, oh, very good. The permanganate, the purple colored permanganate is turned violet in color. Okay, all right, all right. Now to this, so that violet colored solution is your acidified permanganate. What happens now when sodium sulfite is added? You observe. Oh, you see the color of permanganate is disappeared. Oh, beautiful. So here the permanganate has oxidized your sulfite. Permanganate has oxidized your sulfite to the corresponding sulfate, and the in permanganate, you just pause please. No, with the pause please. No, yes, here. Yes, pause please. Pause. Okay. The in permanganate, you are having your manganese in oxidation, manganese having oxidation number 7. So from 7 in the product, the manganese has attained your oxidation number 2. So from higher oxidation state to lower oxidation state, from say whenever it is come to lower oxidation state, means there is the reduction to your manganese, whereas there is the oxidation to your sulfite to sulfate. So in this way you are seeing that different kinds of your oxidizing and reducing agents, they are playing part simultaneously, playing part. Now you will see one very interesting thing, where here you have seen that different materials we have used, but they are in the same material, both the oxidizing and reducing agents will be there. Means you can say that that is an auto-oxidation reduction or auto-redox reaction. Okay, please, unpause please. Unpause. Here what is taking? Oh, he is taking your ammonium dichromate. Ammonium dichromate is beautiful orange colored solid. Oh, he is taking, he has made a heap of your ammonium dichromate. Oh, here he is taking, this is your ethanol. Just 1 or 2 drops of ethanol is added on the top of this heap. This is just for firing, nothing else. It has got nothing to do with this redox reaction. This is simply for firing, to initiate the reaction. So what happens, as soon as this one is initiated, so the initial heat, that one will decompose your ammonium dichromate to the monochromium trioxide and ammonia. And this monochromium trioxide is a very strong oxidizing agent. This monochromium trioxide has started oxidation of your ammonia produced in the same decomposition product. And you see the ammonia is burning and you are seeing such a beautiful reaction. Beautiful reaction. This is the artificial volcano. So you're seeing this volcano. Now what is the equation? Here you see. Okay, this is your ammonium dichromate, orange color, and by initial heating, it has given you the monochromium trioxide and ammonia. Unpause. Pause. Okay, now this monochromium trioxide is there and ammonia is produced. Now this monochromium trioxide, as I've told you, this is a very strong oxidizing agent. This one has oxidized your ammonia to the corresponding molecular nitrogen and water. And what has happened to your monochromium trioxide? In monochromium trioxide, oxidation number of chromium is 6, and it has come down to oxidation number 3. Here you see the formula of Cr2O3. So this is green. So here you are seeing that red oxidation is taking place in the same compound. Both the oxidizing and reducing agents are there. Now, gentlemen, I have told you so many things about your oxidation and of course simultaneously reduction. Now you see this oxidation or this combustion process, this one is going on inside our body even. How in our body this oxidation process is going on? This oxidation process is going on in our body. This oxidation process is going on in our body. How? This oxidation is making us alive. Let me tell you that we are inhaling oxygen. So this we inhale oxygen via air. And as soon as oxygen we have inhaled, this oxygen is getting carried over by the hemoglobin of our blood to all the cells of our body. We are taking food also. And among the food, your carbohydrate, protein, and fat. These things, in molecular level, these are again going via your, say, blood. So blood is carrying all these foodstuffs to all the cells. So in the cells, our foodstuffs are also going, your oxygen is also gone, but they will not react so easily. Catalyst. Now, in cell, we are having a beautiful chamber that is called mitochondria, you know. This mitochondria is termed as also the battery of the cell. Now what happens? This mitochondria is supplying some specific enzymes. These specific enzymes, they are now making your foodstuffs to be burned by the help of oxygen. Means indirectly, oxygen is oxidizing your this foodstuffs, and the amount of heat that one is developed, heat that one is evolved, this heat is maintaining our body temperature, and it is just getting utilized for all the different other thousands of reactions that are going on inside our body, and it is keeping us alive. Now we are almost going to say stop. Now before that, let me tell you about the beauty of our nature. You see, in nature, we are having our air. Air, remember, nature is the greatest scientist. It has maintained the percentage of your oxygen and nitrogen in air in such an optimum condition that, let me tell you how the beauty is. The beauty is this, that during our lockdown period, we were suffering from the, deficiency of oxygen, and for procurement of your oxygen throughout the world, there was very much hue and cry. Now one fellow, he told me, sir, if nature would have been 30% of oxygen in air, then this problem would have been there. I told him, oh my goodness, if 30% of oxygen would have been there in nature, then there would have been a havoc. How? The heat from your sun's ray would have been sufficient enough to burn almost all the inflammable materials present in our earth, which is stable under normal condition at our present condition, it is stable. All this would have been burnt down. So you see the problem. Okay, now come. If the nature would have, say, lower quantity of our oxygen, in that case, what would have been? Say, the oxygen's percentage, instead of 20, it is, say, near about 13 to 14%. Oh, then there would have been also a problem of your breathing problem. Because of insufficiency in oxygen, we would have suffered from breathing problem. Not only that, we won't have got our fire so easily. The firing also, I mean, the combustion, the burning would have also become very difficult, and we could not even cook our food also properly. So, gentlemen, please try to preserve your nature. Nature is balanced, say, balanced condition. So please try to preserve the nature at any cost. With this much, thank you and goodbye.
Thank you, sir, for your interesting presentation. I think one of the important component of this month's theme was joy of learning basic science, and how a joyful learning can be beautiful and it can draw the students' attention is very important. Because if we want to have achieve Atmanirbhartha through basic science, first we have to draw the brilliant minds towards the science. So in that aspect, actually, Assam Science, Technology and Environment Council is also taking some initiative. Before going to the next presentation, I just want to highlight one or two slides so that in some of these programs, our Professor Pannalal Goswami is also regularly contributing. I'm just sharing one presentation, one or two slides, 3-4 slides. Is it visible?
Yes, sir.
Right. Okay. So, all the initiatives we have taken by ST Council in popularizing science, particularly the basic science understanding. We have a scheme called Student Science Projects, where we encourage the final year postgraduate students and BTech students to do their experimentation, innovative works and culture. And everywhere we support around 20 projects from different students. And many innovative ideas are regularly coming up through these projects. We are documenting of some of these initiatives taken by the students. So it is a very popular program in our state. We are getting proposals from different universities and engineering colleges. Another scheme is Aryabhatta Science Centers. You know that we have 219 Aryabhatta Science Centers. Its main objective is to build scientific attitude among the school students, to make science education exciting through experimentation and other hands-on activities, stimulate scientific temper for innovation, to promote basic science as a career. Here actually in every Aryabhatta Science Centers, we are providing science kits, telescopes, and audiovisual facilities so that they can go to different schools and let the student enjoy different aspects of basic science, physics, chemistry, maths, biology. And we have a trained coordinators, trained teachers, and they are doing all this kind of thing. One of the important program we are implementing through this is science exhibition at the block level, then district level, and at the national level. And moreover, we have another program called grooming and mentoring of students. Here what we do, we select some brilliant students at the rural area. And we have a group of people called science and mathematics facilitators. And we have a 3 days camp where in the 3 days camp, all the students, identified students, do hands-on experimentation, working, and we some kind of counseling for a career development also it is going on. And through this program, we are getting very good students, and they are drawn towards the basic science and other field of science and technology. And I've already mentioned that the Radio Astronomy Center is there in Cotton University, where actually we are popularizing the subject of radio astronomy, which is a very one specialized component of basic science education. We have a small radio telescope, and every year students come there and learn different aspects of astronomy. And we guide. It is not only for the Cotton University, from the other colleges also the students are coming regularly. Then Science and Mathematics Facilitators is an important program for us. At present, we have around 80 Science and Mathematics Facilitators engaged in different schools. And they are regularly helping the students in understanding science through hands-on activities. And they are helping students in participation in different competitive programs, also like Children's Science Congress, Science Olympiads, Mathematics Olympiads, like that. And these are some of the small initiatives our council is taking up. These are science math facilitators, how they are engaging children. There is a grooming and mentoring students, I have already said, how the students are engaged through hands-on activities. So the National Children's Science Congress, I need not have to elaborate. This is an important program of the Department of Science and Technology, Government of India. And in Assam, our state government is also extending very important support for this program. Every year, 10,000 to 15,000 students are participating here. And this is a very good platform for project-based learning of science and science. So thank you. And with this, I highlighted some of the initiatives we are taking in popularizing basic science in our state. But though there are only 3-4 slides to these 3 programs, we are having large number of programs throughout the year. Very soon we are going to have the state level meet of Atmanirbhartha Science Center, where the students, the innovative ideas of different students from all the blocks will be displayed in IIT Guwahati campus during 22nd to 24th June. I welcome all of you to come and see what actually our students are doing through this Atmanirbhartha Science Center in understanding basic science and innovative practices. So thank you very much. With this, I want to move on to our next presentation by Dr. Prasanta Kumar Saikia, who is an Associate Professor of Department of Physics, Dibrugarh University. He has over 20 research publications in the field of thin film devices, material science, solid state physics. I think his deliberation will immensely motivate all the young participants here. I have seen some students in the classrooms are also there today. It's a very welcome step by. I thank the coordinator for bringing in the students, for involving students, school students in this program. I welcome Dr. Prasanta Kumar Saikia to start this presentation. It is over to Dr. Saikia.
Thank you. Thank you, Dr. Barua. Good afternoon, everybody. Professor Guragohai sir, our former Vice Chancellor of Dibrugarh University. I'm Prasanta Kumar Saikia from Department of Physics, Dibrugarh University. So I also convey my respect to Honorable Goswami sir, so from Department of Chemistry, Cotton University. So very good morning to everyone. So I'm going to present my talk, very simple talk. Actually, this is not talk, or I can say it is about this is a discussion. Okay, because physics. What is physics? Let me actually give the presentation. Is it visible? So is it visible?
Not yet, sir.
Not yet. Not yet.
Hello, sir.
Is it
Hello.
visible? Is it visible?
No, one.
Nine.
Sir, you, yes, sir, it is.
Yes,
visible now.
yes, visible.
Yes, visible. No? Okay. So,
Sir, can you try to make it full screen?
okay. Is it coming? Is it visible?
Yes, sir, it is
Yes,
visible now.
okay. So,
Okay, thank
my given topic is the importance of physics for technological development. Okay. First, let's see what is physics. Physics is a branch of science deals with the nature and properties of matter and energy. The subject matter of physics includes mechanics, heat, light, and other radiation, sound, electricity, magnetism, and structure of the atom. So, physics, the branch of science, deals with the nature. The nature is the physical world. Actually, nature is the physical world. Actually, the physics or laws of physics are based on the laws of nature. So, these laws of nature, what are the laws of nature? We can see that how these laws of nature can apply in technology. That is, what is technology? You can see that what is technology? Technology is the use of scientific knowledge or practical purposes or applications, whether in industry or in our everyday lives. Machinery and equipments developed from the application of scientific knowledge, and the branch of knowledge dealing with the engineering or applied sciences. Okay, I go to the second slide. So it's a branch of science deals with the nature. So if you go to the deals of nature, there is actually the laws. Laws are that is laws which are actual phenomena which are already in nature, that it can be relates the natural phenomena, which gives us some law that is invariant. Okay, that's invariant. That's not changes. The laws are not changeable, and it remains fixed, and it can be used for other physical phenomena. Say we can consider the Newton's laws of motion. We can consider Newton's laws of motion. If we go to the mechanics, it is from the nature laws of motion. We can consider this inertia, then laws of inertia. That first law we can consider, and then equation of motion, which gives which can be derived from the Newton's laws. So the Newton's laws, we can see that every action has equal and opposite reaction. We can see from these laws how these laws can be applied in different purposes. Every action and reaction we can consider from a mechanical purpose. You can consider mechanical laws. I shall discuss it later on. Again, see the nature. We can consider, if we observe the nature, the planetary motion, the Kepler's laws. Okay, the basic physics, Kepler's laws. We can consider these laws to study the motion, how they moves. We can consider in the nature. We can see how the sun emits energy, gives us energy, and other things. All the plants gives us some. Gives us oxygen, and then the plant can be used. These all the things are actually there's some phenomenon behind these phenomena. This is our science. Science actually, though it's a natural process. This natural process, how this we can consider how the leaves of a plant produce their energy. We can consider by photosynthesis. This chemistry is also related to that. Purposes we can use the trees or for different purposes. So in the nature, so nature phenomena or nature laws, you can see that can be used for practical applications. Okay, so now we go to the energy. Energy, we can consider what is energy. Energy is the source. Energy is the basic point, which is the all in all. You can consider energy. If there is no energy, everything is we can consider as nothing. If the energy is no energy, then we can consider void, or there's nothing. We can consider it. That is physical world. We can consider it. The existence of physical world may not be there if there is no energy. So these different laws we can consider the physics include mechanics, heat, light, and other radiations. So in mechanics, we have different laws. So the basic law of mechanics we can consider Newton's law. We can consider Newton's law. The other laws are there. We can consider Archimedes' principle or other laws. But these laws are actually derived from we can consider that Newton's law of pressure. We can consider other the terminology of terms we can consider from other laws. Similarly, that heat, energy, heat, then light. We know that light, basic laws of light, reflection and refraction. Based on these laws, reflection and refraction, we can consider from basic laws of reflection and refraction, we can consider how light waves travels. Only they must obey the laws of reflection when light travels. Again, we know that light, what is light? So light is an electromagnetic wave. We know that light is an electromagnetic wave. That wave propagates. That's the light propagates when they propagate, they obey the laws of reflection and refraction. How they transmit? They must obey the laws of transmission or reflection. So there are other phenomena. When you consider to go to light, there are other phenomena, polarization, interference, and other phenomena we have to consider. So then sound, how we are talking. So the sound is produced, how sound wave propagates. The longitudinal wave. That's again you can consider the electricity, the magnetism, and the structure of atom. Electricity and magnetism. Actually, we can consider that again electricity and magnetism combines to form the electromagnetism. That's a basic phenomenon, electromagnetism, which was actually given by Michael Faraday. Okay, Faraday's law of electromagnetic induction. So these are basic laws of physics, and even we can consider laws of physics, Lorentz force law, and other laws, Coulomb's law. So these laws we can consider that Newton's law governs the mechanics. We can consider Newton's law governs the mechanics, and similarly the Coulomb's law of electricity. Statistical govern the electrostatics. In electrostatics, different laws we can consider Gauss laws, then Coulomb's law. They are all the laws. They are governed by the Coulomb's law. Similarly, the current electricity is governed by the Ohm's law. You know that what's Ohm's law? Ohm's law, when potential difference is applied at the end of a conductor, then the current flowing through the conductor is proportional to the potential difference applied across the conductor. That electricity will pass through the conductor at constant temperature. That remains constant. At constant temperature, we know that that is P is equal to IR. P is equal to IR. The potential difference is equal to, that is, I is the current flowing through the conductor and R is the resistance, the internal intrinsic property of the material. So this is again V is equal to IR. So we have to consider that V is equal to IR. This is a mathematical relation, because everybody knows that mathematics is the language of physics. So there are mathematical relations is expressed when you consider this expressed in the form of mathematics. Because mathematics gives us the accurate measurement. We can consider mathematics gives us whether the measurement is correct or not. So when you consider the force law, Newton's law, we can generally summarize it as force equal to ma, mass into acceleration. So this is also mathematical relation, but what's the physics behind this mathematical relation? That is, force applied to a body is proportional to when it moves or accelerates. Okay, so this force, the acceleration is proportional to the force applied to the body, and is also, it depends on the mass. If it is higher mass, then it is the force required to accelerate the same amount must be greater. So it depends on mass also. So force depends on mass. So force is, we see that force law, we can consider mass into acceleration. Okay, so we can consider different phenomena of mechanics in using the Newton's law. So Newton's law of inertia, we know that Newton's law of inertia or Newton's law, a body will remain at its position of rest or it continues position of motion unless acted upon by an external unbalanced force. So this phenomenon is used in different applications when we go to the applications. So these are basic, very fundamental. Actually, I'm doing a very fundamental. We can consider structure of atom, the nucleus at the center, and the electrons revolve around the nucleus. Revolves around the nucleus, and the proton in the center. Sorry, the nucleus, the protons and neutrons. Proton convert to neutron, neutron convert to proton by different mesons, or they are sending their energy, or they do. We consider it positive, nuclei positive, then electron is negative. Okay, so then when you consider the atoms, then the electrons evolves around the sun. We can compare it with our planetary system. The nuclear, the sun is the nuclear, our planetary system, and we can consider we are electrons. The Earth or other, we can consider that the electrons. You can compare like that. This is system. There are systems. They are revolving around the nucleus. Our Earth is revolving around the sun, keeping sun in the. This can be explained in terms of the Kepler's planetary motions can be either Kepler's law or see. So these are, so we can see we can go to the next slide. Say this technology. You can see that technology, the use of scientific knowledge for practical purposes of applications. Okay. So you see that generally physics generates fundamental knowledge needed for future technological advances that will continue to drive the economic engines of the world. Okay. So physics generates fundamental knowledge, basic knowledge, because we know that everywhere is physics, different laws of physics. We can explain different laws of physics to use in different applications. So you say that the Newton's law, it's applicable. Newton's law is applicable for, we can consider to launch, say, rocket. Every action has equal and opposite reaction. So there's some combustion engine already. Some is told about the combustion process. He showed the combustion process, and you can see that the rocket engines. Then when it is pumped and burned inside the chamber, then it goes in the one direction. When it bursts in one direction, then in the other direction, rocket will propagate. So in this, physics contributes to, so technological infrastructure provides trained personnel to take advantage of scientific advances and discoveries. So we can go to some basic laws of physics, importance and application. See that basic laws. So we can go to the Archimedes principle. So first we can go to Archimedes principle. So when a body is partially or totally immersed in a liquid, it experiences a thrust force which is equal to the weight of the liquid displaced by the body. We see that when you consider a boat or ship floats on or sails on water. So when it is designed, okay, when designed, to consider this Archimedes principle. So it's based on this principle. How it can be designed? Because it has to be float. Okay, that is the body is partially or totally immersed. We can consider partially immersed. It experiences thrust force, which is equal to the weight of the liquid displaced by the body. So we have to consider weight when the ship is designed. We have to design such that is the liquid displaced. The weight of the ship must be less than the weight displaced by it. So this flat, what will be the weight? Weight is the nothing but mass into the product of mass and the acceleration due to gravity, mg, acceleration due to gravity. So mass and the pressure, force per unit area. We know that pressure, force per unit area is force exerted or weight or downward force exerted by the entire surface must be smaller than the thrust or buoyancy of the liquid. So this principle is used to design a boat. So this is the designing a boat is a technology. It is the technology. So it's a very simple example. It's a very simple examination. Technology nowadays, what technologies are actually technologies are designed or technologies developed. Okay, it's very highly, actually very high. So all the factors you have to go when we design what type of material we have to consider we have to control the weight of the boat. So weight of the boat, what type of material we have to consider, because each material have different weight with a molecular weight, right? So depending on that molecular weight or weight, the entire weight of the ship. So material selection or different parameters, we have to consider different parameters that would be different. So this is a simple example. So we can go the Pascal's law. So Pascal's law states that pressure applied at any point of the liquid at rest is transmitted without loss. Okay. So I think so figures are not coming. So if we say give the pressure, we can see that hydraulic brakes or hydraulic lifts or other they are designed. So it is Pascal's law. We have to consider Pascal's law. Okay. So from this Pascal's law, so I'm sorry the slides are completely not coming. Applications figures are not coming. So hydraulic brake or hydraulic jacks, they are designed on the basis of the Pascal's law. That is designing the hydraulic brake or hydraulic lift. That is technology. So again, I mentioned about the Ohm's law. Ohm's law is a very important law. I don't consider this Ohm's law, dependence Ohm's law. So when you consider the current electricity is governed by the Ohm's law. So we have considered V is equal to IR. This is the mathematical relation, voltage potential difference. So current electricity. So at this moment, that is actually we are very dependent. Technology is dependent on this law. Technology is very dependent on this law, because when you consider each and everywhere electricity is required when potential difference is applied. So R is the resistance of the metal, but technologies they can design on this the resistance. What is resistance? Resistance of the material is opposing how they oppose the flow of electrons when it passes through the metal. So am I audible? Yes.
Shivani Goswami.
Yes, sir.
Yes, okay. So see that when you go to the electricity, so we are using electricity, but how electricity can be generated? Electricity can be used, or how electricity, that is the important part, how it will be used. Electricity can be used, potential difference we can apply. So electron moving through the material, it may be metal or it may be semiconductor or it may be other components of the circuit. So Ohm's law is a very simple circuit, but we can consider complicated circuit, considering the capacitor, inductor, or that other resistor or other currents into devices. So that is the complete resistance. We can control the resistance. So in case of we know about the transistor. Okay, they can be the resistance of the material can be controlled. The current can be controlled. That is the technology part. That is technologies or technocrats. Basically, technocrats. We can consider engineers. We can consider the IITians. I can see that technocrats. They design these things based on the laws of physics, basic laws of physics. So in semiconductors, we can consider how the electron flows through it, or the current flows through it, how the junction is formed, diode, basically that diode. If you consider semiconductor, that is it's a material whose resistance is in between, we can consider metal and insulator. That is the moderate conductivity. This moderate conductivity. That's actually just to understand. Okay, so resistance can be this semiconductor. It's a material whose conductivity, in general, we can, but conductivity is in between metal and semiconductor. In case of, but the basic property, unique property is that in case of metal, when metal is heated, the resistance increases. When metal is heated, the resistance increases. But when you consider semiconductor, when it is heated, the resistance decreases. That is the unique property of it. This we can consider the negative coefficients of resistivity. So total negative temperature coefficient. That is when temperature increases, the resistance decreases. Okay? So depending on that property, one can consider a device, that is diode. We know that PN junction diode or PN junction diode. Then that means also even the PN junction diode can be used as solar cell technology. That's technology part, how solar cell can be prepared. So these are basic laws. Ohm's law can be used. So Newton's first law I have already mentioned about it. Newton's second law, also F equal to MA. So Newton's third law I have already mentioned. Okay. So Newton's law of gravitation, also Newton's law of gravitation. They are actually, when you consider Newton's law of gravitation, how the massive stars or planets, how our universes actually exist. How our universes exist actually, that is solar system, because of attraction between the different planets, stars. They have some attraction, force of attraction, and they are at a balanced position. So we know that it depends on, for a massive body. So that is it depends on, according to this Newton's law of gravitation, they attract each other, and they are proportional to their product of their masses and inversely proportional to their square of the distances. That is the law of gravitation. On the basic law, that is, we can consider this system, our planetary system exists. So it's a basic law. Then Ohm's law, sorry, it was third law. That's Coulomb law I have already mentioned. Hooke's law, that's one important law in physics. So Hooke's law gives a relationship between the force applied to elasticity, elastic properties related to elasticity. That is our spring. We can consider elastic properties, a property, how that is depending how a body can be compressed or stressed by using force. After removing that force, it may go to their original position. That is all material. That is property, elastic property. So that is the spring is also elastic property. So if you consider metal, you can give force, force from all sides, then it will be compressed. If we remove that force, then it will be released. So again, when we can consider again also, if your body is heated, then there will be some expansion, and when it is cool, there will be contraction. Contraction. These are some properties. But we can consider this elastic property, or say properties, thermodynamical property, different properties are there. So Hooke's law, then again we can consider Faraday's law. There's one important law, Faraday's law of electromagnetic induction. So whenever a conductor is placed in a very magnetic field, an electromotive force is induced. So it is very, very important law, basic law. So basic law, and so actually it is included in Maxwell's laws. We can consider Maxwell's equations, Gauss law, Faraday's law, then Ampere's circuital law. These are with Maxwell's correction. These are laws of electrodynamics. That's Faraday's law. One important. That's how that we can consider nowadays how the communication takes place. We can consider that communicate. Thus, the electromagnetic wave propagates from one place to other place. What we using the mobile phones, how the signal we are getting, signal is we transmitting. These are actually based on these laws. Actually, Faraday's how they are produced, and then we can consider is Faraday's laws. So Faraday's laws, then Boyle's law, then we can consider when a pressure is applied to a volume, we can consider volume. Okay, so pressure is inversely proportional to the volume of the material. So when pressure is increased, the volume of the gas or the material there decreases. So these are actually basic phenomenon of physics. So that can be applied in using or technology. That is applications. So when you consider engine, so we can consider generator. Say we have to consider the electromagnetic induction when we consider a fan. So current is passing through a coil. So in the magnet field, okay, passing through. So current is passing through the coil. Okay, that coil. Okay, that because of that coil, what happens? A magnetic field will be developed. Okay, that magnetic field will develop, and also with the fan, or you can say that in the motor, things are there. A magnet will be there. That magnet will repel the armature or rotor or the stator. We can consider root, or it may be rotor. They will forced to move the fan or rotate. So this is a very simple application. So when it's applied in application is there, apply the basic laws, we can apply this basic laws and basic rule, and that we can get the different actually application, and we can use in our day-to-day life. It is very simple actually idea. Actually, when you consider these basic laws in technology, so all the basic laws are important for technological development. So without physics, okay, without laws of physics, you can consider laws of reflection and reflection. Optical communication is not possible. So without Faraday's laws of electromagnetic induction, we can consider the different engine, or you can consider motors where there is some motor or generator. It is not possible without Faraday's laws of electromagnetic induction. So without Newton's law of Newton's laws of motion, we cannot design a device which moves. Then we can consider so all the physical laws. So these are within our limited time. So then I have to complete this talk. So without physics, it is certain that without physics or laws of basic laws, the technology is not possible. The technology, we can say that technology is based on the basic laws of physics, but laws are, when you consider huge technology, or we can also consider IT industries or this technologies or any technology, without physics it is not possible, because physics, on the basis of this we can consider technology is a part of physics. We can also consider that technology, or they are bound together, they move together hand in hand for our development of our humankind. So thank you all. So thank you.
Thank you, sir. Joypur sir might be busy.
Actually, am I audible?
Yes, sir.
Actually, slide is not.
Hello. Okay, I'm speaking from another computer. So thank you, Dr. Soitia, for your nice presentation. And you have nicely elaborated how different theories of physics can help ultimately in development of technology and applications So that is why basic science is very important for any kind of development. Because in the welcome address, our director said about that. Yes, technology is the most important, but technology cannot be developed without development of basic science. And that is the spirit of this month's theme of basic science for Atmanirbhartha. So thank you, Dr. Soitya. We would like to interact more with you in future.
Thank you very much.
Final
Actually,
presentation
within a limited time,
today
actually, just I
in this
like to.
session by Dr. Anupam Soitya. I think all of us know about Dr. Anupam Soitya. He's a well-known mathematician across the globe, and at present a professor in the Department of Mathematics, IIT Guwahati. He is known for his work related to arithmetic numbers, number theory, in particular applications to Iosawa theory and p-adic measures. He has also published articles in mathematical cryptography, and he has a large number of publications in mathematics, and also a very well-known teacher in mathematics. We are very happy to have Dr. Anupam Soitya with us today, and he will be speaking mainly on the role of mathematics for Atmanirbhartha, how mathematics can help in different development process. I welcome Dr. Anupam Soitya to kindly deliver his presentation. It is over to Dr. Soitya.
Thank you. Thank you for your kind introduction and for the invitation. And so I welcome all the participants or the respected guests. So let me first share the slides. And I think, okay, is it visible now?
Yes, yes.
Okay, fine. So yeah, so let me start. Of course, I mean, some of the things that I wanted to say has overlap with the previous speaker. So anyway, so what I'm going to talk about is probably all of us know anyway that mathematics plays a very important role in shaping a country, its society and civilization itself. Because it contributes in two ways, in my opinion. First of all, as a discipline, it trains us to think numerically. And it is very much essential because after all, after a point, we have to come down to quantity. Like if we are thinking of economic activities or science or technology, so this numerical data, numerical estimation, so we cannot escape that. It is very much essential and we need it in that basic sense. But I think it is also equally important, if not more, that mathematics trains us to think logically, and it influences our thought process, and it influences our views about life. So in general, it actually that way it is intrinsically connected with our thought process and how our society evolves or the civilization itself. It can influence, and of course we know that how science is influenced by mathematics. Like already the previous speaker has highlighted, and I'll also mention a few things in that direction. And there are so many things to say how mathematics can play an important role. But maybe I'll just mention one particular aspect, which is something that I also a bit worked on. So this is cybersecurity or cryptography that I will briefly talk about towards the end. So probably I'm starting at 12:50. Okay. Yeah. So yeah, before that, let me just give a brief historical outline how the subject evolved. And we know that it has a very long history, and it started with numbers. Basically, mathematics started with numbers, although it doesn't end with numbers. And probably we can attribute to Sumerians and Babylonians in Mesopotamia, between the rivers Tigris and Euphrates. Okay, and then Egyptians, they also contributed heavily. But very few surviving evidence. Only in papyrus they used to have some writings and all. So, and then of course we have the Greeks that we'll see in a great detail, that Pythagoras, Euclid, and Archimedes. And then of course we know about Indians, Aryabhatta and Brahmagupta, among many others. I'm just mentioning a few names, the key contributors. And then like these Europeans took over, and we have this Fermat, Descartes, and Newton, who is not just a physicist, but of course, the mathematicians claimed him to be one of their own, and then Euler, Gauss, etc. And as it is Gauss, who is also a physicist, who says that the mathematics is the queen of sciences. So it shows how significant it is. So my way of bringing it in is that mathematics is essential for all the sciences that I will briefly talk about. And of course, basic sciences needed for technological developments, and which certainly we need for the growth of our country or any country in that sense. Yeah, of course, but as a discipline, there are like two views. There are mathematical giants who prefer to study mathematics for its own sake and without worrying about its application. Okay, and that view is still prevalent to a lesser extent, probably these days, because people prefer it for its as an autonomous intellectual discipline, as an art form on its own, because it expresses beauty in terms of axioms, theorems, logical reasoning, and numerical relations. So some people do not worry about the practical applications, but this aspect itself influences our thought process. And as I said earlier, that our logical thought process evolves. And they were like Pythagoras and Plato among the Greeks who prefer to think of mathematics that way. And there's another European, Jacobi, who thought that mathematics exists for the honor of human mind, because it stimulates abstract thinking and the logical power is enhanced. So that way itself, it influences all of us. But of course, the previous speaker has mentioned, we know about Archimedes, who probably is the first mathematician, we can say, who applied it in the physical world, in the study of the physical world. And in some sense, he anticipated modern calculus and analysis even, because he considered this concept of infinitesimally small. And he rigorously proved a range of geometrical theorems, including the area of circle, surface area, volume of a sphere, area of an ellipse, etc. Okay? Because one important aspect of mathematics is its rigor. We know that mathematical truths are basically, mathematical statements are either true or false. There are very few statements which, you can say, contradict themselves. Of course, there are certain paradoxes, but there are very few in the fringe of mathematics. And we all know about his contribution to physics, and all these laws actually are mathematically expressed. So this law of the lever, or the law of buoyancy, etc. But in sciences, what is the significance or role of mathematics? Of course, the first pillar of mathematics, or first pillar of sciences, is probably the experimental method, which was espoused by none other than Francis Bacon. And then Galileo himself was a proponent of the experimental method, but he was probably the first one who wrote about the significance of mathematics as a language of science. This is his famous quote that basically essentially says that the universe is the book which is written in the language of mathematics, because all these characters, they are basically mathematical. So he emphasized the use of mathematics as a language, not just as an independent discipline, but also as a language in which physical laws can be framed. And of course, then we had Newton, who wrote Principia, and in this book, he emphasized that mathematics is not just a tool, but a language in which science is conceived and expressed, which he himself did to a large extent. And he basically validated what Galileo said. So we can say that after experimental methods, this mathematics is the second pillar of sciences. And of course, we have many examples how Newton's discoveries they were expressed in mathematical terms, like this force as the product of mass and acceleration, or the law of gravitation, which is basically simple mathematical equation involving masses of the two bodies under consideration and the distance between them. So these physical laws, they can be simply expressed in mathematical terms. And we can see that the significance of mathematics in the study of physics or the physical world. And not just in classical physics, but even in modern physics, or in Einstein's theory of relativity or special theory of relativity, or his famous equation E equal to mc squared. Okay, it is nothing but a simple mathematical equation. Or there's Lorentz transformations, or even this the laws of electricity, magnetism, etc. So since already the previous speaker has touched upon these points, so I'm just briefly going through those. And quantum mechanics itself is like, we can say that it is all mathematical. Okay. But not just for expressing the laws of physics, there are certain universal tools, we would say. For example, the statistical methods. It is necessary not just in physics, but chemistry, biology, or economics, any field you name it, these statistical methods, they always help. Okay, so we all know what statistics is. It's the branch of mathematics that studies collection, analysis, interpretation, presentation, and organization of data. Okay, and this field relies heavily on differential and integral calculus, linear algebra, and probability theory. Because what happens in often we have large volume of raw data, and then we have to draw the essential conclusions. We have to interpret the data, and in doing that, and that is needed in all activities. In economic activities, it is needed, or in all experiments, it is needed. So it's a very essential tool that mathematics provides. And of course, it is important for communication, because what we have obtained through our experiments or research, then we have to present it to others also. And it gives credibility, because whatever our results are, they have to be supported by statistics. And another tool is the mathematical modeling, because when we want to understand the functional relationship among various parameters, then this modeling helps. First, one has to, of course, develop a conceptual model of the physical system, and then a mathematical model is formulated, so that we can study the quantitative behavior of the system. And if a simple model can reproduce the prototype, then we can relate to the real world processes, and we can ignore the less necessary elements. So this is a very essential tool in many aspects, so to speak. Okay, and of course, computer programming. We know that it is nowadays like computational mathematics is the third leg of science, because computational data validates all our theories. Most we can see through numerical data. We can if we have proved something, or we have formulated a theory, and we need the supporting data. And how do we obtain the data? In mathematics or in physics, we perform experiments. Then we have to run it on computer also to see whether the data is supporting what we have formulated. Okay? And it is certainly crucial for discoveries in mathematics itself. We all know that one counterexample is enough to disprove a theory. In mathematics, we need just a simple counterexample to throw out a possibility of a theorem. Whereas if some statement is proven, then all examples should support it. And in generating these examples, this computational mathematics really helps. And this is the one that I want to spend some time on, although I have only one slide for it. This is cryptography. So what is cryptography? It's like hidden writing. Cryptos mean hidden, and graphene means writing. And so these two are Greek words. So why it is important? Because of course earlier time, because what it happens now nowadays, this communication is very important. But when we communicate, we often use public channels. Like for example, we talk over the phone, or maybe we are sending emails or WhatsApp messages, and we don't want others to see it. Only the intended receiver should be able to see what we have written for them. But since we are doing it through, for example, if we are sending an email, no one else should be able to access it. So how do we ensure that? So cryptography is that branch of mathematics, that it is the study and practice of communicating messages securely. Okay, so that no one other than the intended receiver can access the message. Okay, so it involves two steps. First one is the encryption. So like the common whatever message is to be communicated, we have to convert it to numbers, and then we encrypt that number, because there's an algorithm to simply change letters into numbers. So certainly we can convert a message into numbers, which is simple. But if we just communicate that simple number, I mean number as itself, then anyone will be able to get the message. So for that, that number is gets hidden, or it is encrypted, and then this encrypted number is received by the receiver, and then he has to, or he or she has to decrypt it, and that involves a secret key. So in fact, most of the cryptography I'm talking about is known as public key cryptography. So anyone can send message securely to a particular receiver, and the particular receiver can decrypt it using the secret key. And it is essential for example, like in function of banks or emails. Of course, WhatsApp messages are also encrypted, but it is not this RSA cryptography. But yeah, so some mechanism is there also to encrypt and decrypt. So, but the mechanism that is fairly common and very easily understood is known as the RSA algorithm. It is named after their inventors, this Rivest, Shamir, and Edelman. Around 1977, they discovered. They were like researchers in MIT lab, and it is based on a very simple mathematical principle. It is very much time-consuming to factorize an integer which is product of two large primes. So maybe to explain it to students, if some students are present here, like suppose I ask someone to give me the product of say 37 and 41, it will not take much time. But on the other hand, if I give the product of 37 and 41 and ask someone to factorize, it will take some time, because normally what will people do? They will try factorizing with 3, 5, 7, 11, 13, like that. So it will take some time till they reach 37. But imagine if we have two very large primes, suppose 100-digit primes, and if we give the product to someone, then to factorize it, even a computer will take years. And this RSA cryptography is based on that it is very hard to factorize. And that's why people are always interested in finding like this factorization algorithm, improving the existing factorization tools. Okay, but since it is very time consuming, this message can be communicated very safely. It can even be published in a newspaper. Like if we want to send our message to someone in particular, we can even print it using RSA cryptography, because it is not easy to break. It is not easy to break. But to explain it in further details, it will require some certain technicalities, which I am not doing because the talk duration is short. But that itself is a very elementary mathematics. It is like congruence, which was in fact developed by Gauss, maybe like 200, 300 years back. It was Gauss, and it is very elementary mathematics, so to speak. the mathematics which was discovered maybe 200 years ago, that only suffices for RSA crypto system. But of course, there are like other crypto systems like using elliptic curve, which are more involved, and they are more economical in the sense that the computational time, the encryption time or decryption time, that is less, etc. But the point that I want to emphasize is that mathematics is important in cybersecurity as well as digital signature, because another important aspect is like digital signature. And during the time of COVID, probably we realized its significance even more. Like we don't have to physically sign, but we can do so digital. And this RSA crypto system or RSA algorithm that I just mentioned, that can serve that purpose as well. But remotely we can sign, and it is very much needed. So basically, I want to conclude that why mathematics is important. Okay, that it provides a way of observing facts, of detecting patterns, and finding order amidst chaos. But it is also a vehicle for rational thought. Okay, so because it trains us to be more rigorous in our arguments, and we can conclude that it is why it is important, that it is not just only for its tools, but as a language as well as the logical training that it provides. And that's why, I mean, and because of its it is very much essential for all branches, all various disciplines. So I think it is the school education itself, we must give a sound training to all the young kids so that it gets popularized and they get attracted to this discipline, and they can have the ambition of applying mathematics in various other fields. So basically, that's all I wanted to say, that this mathematics plays a very key role in three aspects. Is as a language of science, or the logical thinking that it trains us for, and also it's these tools that it provides in technology. Okay? So I'll conclude with that, and yeah, thank you for listening to my talk.
Thank you, Dr. Anupam Saikya. Very nicely. Hello. Hello, am I audible?
Yeah, you are audible.
Yeah. Okay, thank you, Dr. Saikya, for very nicely elaborating this need of mathematics. So whatever you said, that mathematics is needed for transformation of society, not only for tools, but for the language provides for scientific discourse. That is very important. I think this is the spirit, and we should understand mathematics not only for ourselves, but for the overall national development, because all the development programs, you need the mathematical precision, numerical precision. Otherwise, all our development plannings are not going to be successful. And another very important aspect you have mentioned about this cyber security, cryptography, and now this new generation of students should understand about the importance of these things. I think very soon we'd like to have a very good interaction with our students through our Aryabhatta Science Centers and other programs, to bring to IIT for having some interaction with people like you. Thank you very much, Dr. Saikya.
Thank you.
We look forward for your continuous association with STEC, and thank you once again.
Thanks.
Now we are coming to the conclusion of today's webinar. Now I invite Mr. Biman Barua, Scientific Officer of STEC, to offer the vote of thanks. Over to Biman.
A warm and graceful afternoon to all of you. It is my privilege to propose a vote of thanks and acknowledge the contribution of who worked hard to make this Vigyan Utsav celebration happened. I, on behalf of Assam Science, Technology and Environment Council and the entire fraternity of the council, first of all, extend my most sincere thanks to Dr. Devopriya Dutta, advisor and head SSTP DST Government of India. Thanks to Dr. Rasmi Sharma, DST Government of India, for her support and guidance for organizing of this Vigyan Utsav. On behalf of STEC, I extend my hearty vote of thanks to our honorable speakers, Dr. Alok Buragohai, Honorable former Vice Chancellor, Dibrugarh University, Dr. Pandana Goswami, former Professor, Department of Chemistry, Cotton University, Dr. Prasanta Kumar Saikia, Professor and Head Department of Physics, Dibrugarh University, Dr. Anupam Saikia, Professor, Department of Mathematics, IIT Guwahati, and they spared time from their busiest schedule to grace this occasion. Today, we had an opportunity to hear your thoughts, and this will surely be going to encourage us in our future events. Your thoughts have enlightened our minds and have shown us new path, and my gratitude to all the members of the State Assembly Council of the entire country. And especially thanks to Tamil Nadu Assembly Council for coordinating these events. And a special mention to our director, STEC, Sri Kinni Sangshan, for her dynamic leadership. With deep sense of appreciation, I thank for her efforts. I would like to thank Dr. Joydeep Barua, Head Science and Technology Division of STEC, for his effort and make this event successful. Thanks our participants. To go to all the participants and well-wishers and support and encouragement. Special thanks to our block coordinators of Aizabato Science Center, all the district coordinators, science and mathematics facilitators, and teachers and students of the state. Without their support, we are not been able to achieve our excellence. I also thank to our Subhankar and Rahul for their help, and thank all the members of the Assembly Council, STEC, for a cooperation for organizing this event. Last but not least, thank you to each one of you who made this Vigyan Utsav successful. Thank you. Over to Dr. Joydeep Barua.
Well, thank you once again. So with this, we are concluding this today's session. Thank you very much.
Thank you.
Thank you.